Hello, hello, hello. The pleasure itself is mine to elucidate yours about the time period of mine at the Department of Physics between September and January, which elapsed expeditiously and had fallacious trepidations that were all in vain, and which neither I myself found that very opportunity to record the videos I promised and mentioned long time ago, nor had I spent my whole time without quantum mechanics and electromagnetic theory, and by the way, the cosmology. But the season itself completed with diligent success and assiduous calculations. So I arrived back home 2 days ago, and the purpose of this short video is to enlighten you about what really is coming on for the semester plan. And it was about actually the inflationary cosmology. But permit me then to enlighten you about what really happened between this season, September to the January. It was about actually the cosmology. And I was studying the FRV cosmology for the cosmological models and actually Robertson-Walker metric. So the contributions of the expansion were presented by using the conformal time, and which we have solved the accelerating gravitational field, which is a non-stationary field, and which you may see or maybe have seen from previous videos of mine that I myself recorded on the chalkboard as I was working. So there were contributions towards the expansion of the universe, and which are actually the fields, the matter, and the stationary fields are being non-stationary when you put any fluctuation inside of it. So it becomes non-conservative. So it's going to be the problem actually. So those are just the second plans for the cosmology tree. But in the second video, we are assiduously looking forward for the solutions in radiation and matter-dominated case, which are including the curvatures and the conformal time situation. So we are about to calculate the event horizon, or maybe the horizon distance of the universe, which is corresponding to the radius of the universe from the Big Bang. So those are, as you can see, the assumption of ours is actually the very beginning is t equals 0, which is corresponding to the Big Bang, but it's not true that much. It's just a phase transmission into the this universe, but we don't know what it was in the previous case. So the other one is actually about the quantum mechanics. Yeah, and there were three essential postulates. For example, the wave functions are also specified into the particles that they are corresponding and which are normalizable, and which the operators themselves are specified, and by the way indicates the physical observables. So they are, the wave functions, for example, must be normalizable wave functions, that the space components are going to infinite. Okay, so the wave functions must be limited so as to make them normalizable wave functions, and which are corresponding to the physical observables we are measuring in the physics. So actually there were potential barriers, and the Heisenberg and the Schrödinger picture, where the quantum state becomes time variable. So these are just non-stationary cases actually, where the Hamiltonian operator is dependent into the time. So it evolves by the time. Well, there were essential cases that we have solved: the angular momentum of the hydrogen atom and the corresponding quantum numbers, angular momentum, magnetic quantum, or whatever, the main quantum number, doesn't matter. Those were, wow, it was amazing and miraculous consequences I myself reached, and completed the courses from MIT lectures, and which is actually Professor Ellen Adams. And from the cosmology, I have completed the Ellen Good's videos, and I just rewrite in the whole book the Griffith's quantum mechanics and the Geiserowicz's quantum mechanics, which you can see in here. No, you don't see that, I'm pretty sure of this. So yeah, the topics are amazing, and looking forward to record those videos, but it will take a time because I am in the Department of Physics, so I couldn't find any time to record something, maybe on the chalkboard. So this semester is available to record the cosmology and inflationary cosmology, is the second video, and yeah, for electrodynamics, by the way, and which will be in Turkish language. So thank you so much.